Hello everyone, welcome back to our channel. Today we are going to discuss about properties of ionic compounds. Ionic compounds exist as solids due to strong electrostatic forces of attraction. NaCl compound, it is a ionic compound. Sodium atomic number is 11. The configuration is 1s2, 2s2, 2p6, 3s1. Chlorine atomic number is 17. 1s2, 2s2, 2p6, 3s2, 3p5. In chlorine, it has short of one electron to get octet configuration. In sodium, whenever it lose one electron, it will get stabilized. So whenever it lost one electron, it forms Na plus, that is equals to ionization energy or ionization potential. In Cl, whenever it gain one electron, it gets octet configuration, it forms Cl minus ion, that is electron affinity. Here loving electrons. Whenever the bond formed between Na plus and Cl minus, it is NaCl, that is ionic bond. Here completely lost electron, here completely gaining electrons. It is ionic bond. Electrostatic force between opposite charges, that is ionic bond. Ionic compounds don't exhibit isomerism because ionic bond is non-directional bond. Here the bond between two opposite charges. Here one atom is loses electrons, other atom gain electrons. It forms ionic bond. No particular bond angle and structure will be formed after forming NaCl. If observe, sodium has 6 coordination, Na plus, Cl minus has 6 coordination number. If take in 3D way, if Na plus surrounded by 6 chlorine ions, see these in all direction, so non-directional bond, it is in uniform in all direction. They are generally soluble in polar solvents. They are having high value of dielectric constant. What is dielectric constant? Capacity to break the molecules into ions is called dielectric constant. Ionic compounds are the good electrical conductors in molten state or in aqueous solutions. Melting point and boiling point of ionic compounds are very high. If take BaCl2 and BeCl2, BaCl2 has high melting point than BeCl2 because here anion is common. Whenever anion is common, atomic number of cation whichever is having high, that molecule has having high melting point. Here atomic weight of barium is very high than beryllium, so BaCl2 is high melting point than BeCl2 whenever anion is common. In cesium F or lithium F, cesium has high atomic weight than lithium, so cesium fluoride has high melting point than lithium fluoride. Cations having high atomic weight. Whenever anion is common, cation is having high atomic weight, that is having high melting point. If cation is common, compound is having high lattice energy, having high melting point. Compound having lower lattice energy, having low melting point. Lattice energy is directly proportional to charge and high charge and smaller size. If take NaF and NaI, here fluorine has small size than iodine, so lattice energy is high for smaller size containing compound. Here fluorine is the smaller size than iodine, so lattice energy is high for NaF than NaI. Here NaF high has high melting point than NaF. Why fluorine has NaF has a high lattice energy? Whenever size increasing, electrostatic force will be decreased because of higher charge. Here in fluorine, because of small size, lattice energy is high. Whenever small size, electrostatic force between sodium and fluorine very high, it will come closer, it results compact nature. Lattice energy will be high for NaF than other atoms. Thank you for watching.